Okay, you guys. Today's a special day. Today is the Ides of March.
It is the Ides of March.
What's the Ides of March?
At 2 today, when Caesar was told to watch out.
You guys know what tomorrow is?
The day before.
You pose a question. Are you going to eat lunch at the same time?
Yeah.
I'll just answer your question.
Yeah, I just want to know what's going on.
It'll be easier to understand.
Beware the Ides of March. I didn't cause it. Okay. Okay. Today is the 15th. Tomorrow, it's the 16th, which is Eros. I'm not sure I'm spelling it right. He's Finnish. He is to Finland like St. Patrick is to Ireland. So it's a special week this week. That's tomorrow. Okay, so tomorrow, today is the 15th, and we are going to finish up area problems. We're going to do some multiple choice. And you need to be working outside of class. And Adam and Luke, you need to put your stuff away and need to focus here. And everybody needs to put their phones away and focus, because this is it. We are not coming back to these topics again. This is it. When you come back in April, we're going to go back and review other things, because we only have so much time reviewing a whole year's worth of work. We're just hitting on this hard. So if you're not working outside of class on these AP problems, to me, it's the easiest part of the exam. You might not do well on the exam. So we're going to finish up on area today. Tomorrow we're going to do volume. There are basically 3 things in volume. We're going to do the first part tomorrow. And then next week, we are going to have a quiz, some AP problems, FRQs, right off from the packet. I think Mrs. Hersman said there were going to be 2 of them, something like that. Short quiz. We will do volume. This is day 1. We will do volume day 2. All geometry. Of course, the visualization's hard. The 20th, we are going to do volume. Day 3. Then, on the 21st, we are going to have a review day. You'll be working on AP problems. We're not going to use the book problems. And, 322 is test part 1. 323 is test part 2. They are all AP questions, so you probably will have seen it. I will also try to put together another packet, like the big yellow one of the integration packet. I'll put together one with areas and volumes out of the multiple choice. So you'll have those grouped together. Okay? And then, by the way, as far as I'm concerned, that's the end of quarter. So if you don't have your tests and stuff in, we're done. But most of you have all that in, so it's not a big problem. Because I want to be able to get all my grades done before spring break. You would like to have them posted before that. Okay, 326, we are going to have, and there's another quiz in here someplace. We are going to have the quiz on the multiple choice AP problems that you have. Now, listen carefully. If you did the yellow packet, you'll notice that I misnumbered it a little bit. And where's the problem, Adam? No. It's after 16, there is a problem with a triangle on it. Yeah. Doesn't really have a number. So that one you cannot enter into Skyward Assessment. I double-checked where the problem was, and I believe I'm right. I wish I could take the Skyward Assessment, because then I'd know for sure that I entered things correctly, but I can't. All I can do is edit each problem at a time. It's 31 problems. 30, actually. Okay, so the one underneath the triangle problem is 17, and the one under 17 is 18. Now, if you see decimals down here in your answers, it's a calculator problem. Now, there's something interesting about these problems, and I'm going to talk about that in a second. And then we are going to do, on the 27th and the 28th, I'm not sure what topic we're going to do, but we're going to do AP review. Yeah, I want you to do it, but you can't enter it. We're going to actually do it together in class. How's that sound? Now, rumor has it that, yes? There's a, no, that's moved to Monday, right here. Okay, and the Skyward assessment is due. It is up and running. You can enter your result, your answers anytime you want. But you do have to be complete, I believe. I'll talk about that actually right now. There are 30, I better check because I swear I had 31 numbers on. Oh no, I should have 31 numbers. There's 31 questions, and all you do is you go log into Skyward. Okay, girls? You log into Skyward, and down here on the screen will say current assignments. Or current, I think that's what it says. I don't get to see the screen. I have to look over on my students. And if you were ninth graders, you'd know because they do it all the time. You just click there, and it'll come right up for you. And you can do it on a computer. You can even do it on your smartphone. If you have like an iPhone. Okay, guys? Guys? And you enter your answers. It will tell you, it's multiple choice, so it's a matter of just clicking on a button, and it'll tell you if you're right or wrong. Questions will not appear there. It'll say question 1, and it'll say 1. And then the choices are A, B, C, D, E, and that's going to do the same thing for the answers. Nothing. You're going to have this in front of you. It will tell you the correct answer. And it will go directly into my Skyward account, and so I'll know who did the packet and who didn't do the packet, and what you did, how well you did on
I'll tell
it.
you right now, we're good.
Huh?
I'll tell you right now, we did it.
You need to, everybody needs to do it. Otherwise, I'm not sure why you signed up for the AP exam. You can be prepared for the AP exam easily. Even if you struggled all year, it doesn't matter. If you do the review problems, you will do fine. And come in for help. Another announcement while I'm thinking about it is period 6 is my prep hour. But I do math resource period 5. I get very few people. I get a couple people, but not very often. So what I'm doing is basically staying 2 periods. So period 5, the resource room is still open, but period 6, it will also be open. So if you have a 6-hour open, and how many of you do? Not very many?
And 6.
Well, then I should see you twice a day, every day, besides today in
No,
class.
3 times a day.
I said besides this class, yeah. Yeah. So I should definitely see you. There's no reason not to do well on this exam. There really isn't.
I'll book it in.
Okay, so just to make sure that you know that it is open period 6. So come in and see me. Now, if I'm not there, because if nobody shows up, I end up going back to the office. Just come get me in the math office. It's in 1304. So math resource. Use that. We used to have it years ago, and it was packed. 30 kids every hour. It's 1304. If you have tests to make up in math classes, and even if it's stats, it doesn't matter, you can come in period 6 and make up those tests also. So math resource now is open 4, 5, 6. Okay. Now let's look at some of these problems. We'll do the triangle problem in a second. We're going to come back though, and let's do number 8. The multiple choice. Now, I started saying rumor has it, I never finished. Rumor has it that there are 10 problems in the multiple choice exam that the College Board looks at in particular. Everything's graded, but there are supposed to be 10 special problems that are repeated in some form or another every year. And that's what you got to get right to get your 5. Well, if you look through the packet, you can see some problems that are exactly the same. Problem number 1, for instance, comes back in, is it 20?
Number 1.
It's 20. The only difference is one's indefinite and one's definite. But it's the same question. And I know it was off of different exams. The concept I'm going to look at on number 8 is the fundamental theorem of calculus. And it says, and this you will see, and I'll tell you which problems you're going to see. It's not in the packet. I believe you will have one that's a required problem, so to speak, that looks like this. Oops, that's supposed to say 4. Okay, I know all of this information. Okay, we've seen this problem before, actually, I believe. I think so. So g of x is an antiderivative. There's some clues in this problem. Here's a clue. I have an antiderivative, which tells me I'm going to need an integral, because they even use the word. They give me points on my antiderivative, which makes me think that maybe the fundamental theorem of calculus will apply. And the fundamental theorem of calculus says this: if I integrate from a to b of a derivative, f prime of x dx, that's equal to the antiderivative evaluated at the two endpoints, or it's equal to f of b minus f of a. So when I don't know what to do and I'm looking at it and they give me one of the points of the antiderivative, I'll write this down and see if it might apply. It usually will, because you're going to see this in another problem. So g of x is the antiderivative of little f of x. So that tells you that f of x dx is equal to g of x, and it's going to be evaluated at a and b. I know that, because it says g is the antiderivative. That's what that means. Okay. They give me this. I could choose any values for a and b that I'd like, but in particular in this problem, they give me the 2, and they say find the 4. So this is going to be evaluated at 2 and 4. Well, guess what that is? It's an equation. This is g of 4 minus g of 2. That's equal to this integral. And I know it's weird because you're going to have an answer that involves an integral, but that's okay. And it says find g of 4. So I want to find this guy. How do I do that? Add g of 2. Now, once you've done enough of these, you'll know the easy way to do this. But it might take a little bit of time to do that. So I have g of 4 is equal to g of 2 plus the integral from 2 to 4 of f of x dx. You know what? That was where we started. That was kind of my beginning point. Didn't start at the origin. It started at g of 2, which was at, it was what? -7, right? Plus the integral from 2 to 4 of f of x dx. Now, I always do the problems first. Then I check my answers with the multiple choice answers. Some of you are going to want to go right to, if you don't know what to do, you go right to the multiple choice answers, fine. That net sometimes will tell you what to do. In fact, it kind of does, because they have some integrals on here. What answer is this? E. Okay, so there you go. You got one of the problems done, but it's not on the Skyward assessment. Okay, what other problems are like this? Number 9, right below it, is done in the same way, except it's with the calculator. So 9 is like that. If I keep going through here and I look, by the way, 14 is a U substitution. Remember I said sometimes they give you U substitutions? When you don't integrate, you have to do the U substitution. Yeah, be careful. That's why I really recommend you do the problem and then check it, because it might fall into the trap of getting the wrong answer, because the answer, well, I'm not going to tell you what it is, but I could see how you would pick B. I'm telling you B is wrong. And number 14. And it'll tell you what the right answer is. Okay,
So do you lose? Is it like Quest?
pardon?
Do you lose points for guessing it?
No. And I apologize, I made a mistake. Those guys, 8 is on the answer key, so everybody better get 8 right. It's the triangle one, the one after 16, before 17. It's on Skyward.
Oh, yeah, that is.
But you have to finish it all first. I've tried to figure out a way to give you 2 tries at it, but I'm not sure I can do that. Okay, so the one between 16 and 17 is also a problem like this, and also 18 is just like this. So you can see that this concept is embedded throughout this exam. So that's 3 points. I mean, it might be all in one exam. I don't remember where I got, which exams I got the problems from, but that's a possibility. That's a lot of points that you don't want to lose. The other one is called an average rate of change, but let's go ahead and do this one. Let's do the triangle one, because I wasn't very clever. And then somebody comes up to me and says, why don't you just do it this way? I go, oh yeah, that'll be a lot easier. And there's my triangle. And this is up at 6, and this is 1. Never assume anything about the pictures. This is y, and it says this is, sorry, I can barely see the prime on there. It says the graph of f prime is the line shown. Then they give me f of 0 equals 5, and I want to find f of 1, and I'm given f prime. Fundamental theorem of calculus. The integral of f prime of x dx, or t's, or whatever you want to call them, it doesn't matter, they're dummy variables, is equal to f of x evaluated at the endpoints. Well, I have 0 here. See why I'm going to choose 0? I could choose -1, but I don't know -1. And then I can choose 1. And that's going to be evaluated at 0 and 1. And they said find f of 1. So my integral from 0 to 1 of f prime of x dx, I don't know what to do, so I'm going to blindly do it, is f of 1 minus f of 0. Because I know that. And when you write things down, you start to see what to do. The other thing to do is when you're in the exam, especially if you're getting nervous, just imagine I'm sitting next to you, and you say, I don't know what to do, and what would I say to you? I would say, well, you're given a derivative. What does that tell you? Because, I never answer your questions directly, do I? I won't tell you, this is what you do. You got an antiderivative, so it seems like I should integrate it. Okay, so what is f of 1? It's equal to f of 0 plus this integral. And that's your starting point. So what you're going to do with your starting point is just add it in. And this is f prime of x dx. How am I going to find that integral? Geometry. You know what I did? I wrote the equation of the line. Can I write the equation of the line? Could I just integrate it? Sure. Integral 0 to 1, and we'll just use y equals mx plus b. What's the slope? -6, and the y-intercept is 6. So could we do this? Those of us who are blind to the geometry of the situation, surprise me, I'm going, okay. And I've always done it that way when I've done this problem, and then somebody said, why don't you just use geometry? Because that would be a lot easier, wouldn't it? What's f of 0? That was 5. We should be done with this problem. And how do I do the geometry? It's 1/2 base times height. Somebody said it's 3. It's 6 times 1. That's right. So it's 5 plus 3. And if you don't believe me, go ahead and integrate it. You'll get the same answer. So the answer is 8. So now,
So a lot of stuff.
because it's a triangle,
I got that.
it's 1/2 base times height. What's the base of my triangle? 1. And the height is 6.
So like,
If I can use geometry, I will. Except I didn't.
So you did the calculation part, that was just you.
That was the way my brain worked.
Okay.
But somebody else is going to think that way too. Now sometimes, you guys, shh, guys, I've seen problems on the exam, guys, where you've had to write the equation of whatever the figure is. It was a semicircle. So you had to be able to write the equation of a circle and intersect it with a line.
do the full circle.
Just 1/2 of the other one. It's just the top half. Okay, so number 18 uses this same concept of the fundamental theorem of calculus. You should start to see a theme. I don't know if there was anything else in particular that was bothering you from this packet. Otherwise,
Can we do number, where is it? Can we do,
I'm going to have you guys do it.
14?
14? It's a good question. And, sorry. By the way, 14 is also a common problem that I have seen repeated over the years. Yeah, sorry. And it says, I'm going to take out all those words. It says the rate of change of the volume. Oh, you're right. Oh, 15. Oh, you want to do 14. How about 15? Did you get 15? That's what I was thinking. The volume in a tank with respect to time. What is that then? dV/dt. And then you look at the answers, of course, and they all have, oh, they don't all have dV/dt, but there's some dV/dt's there. So now you can rule out. Okay, I have to fix something. Okay, it says it's directly proportional to, that's this little symbol, it looks like a fish. That means it's directly proportional. It's a multiple of, and it says the square root of the volume. So it's going to be equal to some number, I don't know what, and it's the square root of the volume. Which one is that? E. Okay, that was 15. It's just the way I copied the pictures in there. E and D, what D is? E and D? D is the rate of change of the volume is inversely proportional to the square root of the volume. Okay? They probably wouldn't use inverse. And by the way, this is the problem I've seen often. I've seen a U substitution not every year, but they give you this. And you guys know how to do U substitutions. Well, let's do the easy part first. Now, you have to account for everything, not just the square root of U, because that's what that is. But this is a dx. I can't have a dx and a u mixed up. They all have to be the same variable. And what are the 0 and the 2's? Those are also what? No, they are not u's. They're x's. So guess what? I have to work on this problem and change this one, and this one, and this one. And then in BC calculus, they make the U substitution on the multiple choice even more difficult. So that's how the difference in the levels. Okay, so what do we have to find? We have to find dx. Well, let's find du. What's du? 2. What's the derivative of x is dx. So what's dx equal to? 1/2 of du. That's going to go in right there. And so now we have the square root of u, 1/2 du, and if you don't change the 0 and 2, which answer are you going to pick? B. B is wrong. Guess what? B comes before the correct answer. You need to look at all the answers because they do that to you. So make sure you read through all the answers. Now, if, and then we're going to get into more area problems. If x is equal to 0, what's u equal to? If x is, it's 1. If x is equal to 1, what's u equal to? 5?
It's a 2.
Oh, it's a 2, sorry. My 2 was correct, but my 1 was correct. That's 5, right? And then we look at, and we see C is the right answer. Nice. Now, that we've done U substitutions for a while now, I'm hoping this seems a little easier. But what's nice about this time of year that I really like about this is it pulls everything together and you walk out of here actually knowing quite a bit of calculus. As each little unit went by, maybe not as much as as you needed to, but when we pull it all together, things start to make sense because you start to see the big picture. Okay, I'm going to pause this for a second. Pardon? Question? 22. Ha! I don't know what 22 is, but I don't want to do them all. I want you guys to try them and put things in. Oh, here's what I'll do for 22. I'll give you a hint. Now, some of you want to do a U substitution like all the time. Before I do a U substitution, I try to see if there's an easier way. And the only things you know are x to the n, 1 over x, which is just a special case of x to the n, and e to the x. Well, it's certainly not e to the x, even though it has an e. Because you have to integrate it first. Oh. Am I on the wrong problem again?
No, you're fine. I'm just confused.
On 22?
Yeah, no.
It's just an integral.
Is it the same thing as the one that asked?
Area under that curve. I don't know what that curve looks like. Well, I do if I do my little trick. Because you have to integrate it first. The area is the antiderivative, not the function. Good question. Okay, has everybody got that? You have to find, if there's an area between 1 and e of whatever that curve looks like, what does that look like? What could I do with this? Couldn't I do this? Couldn't I do that? What is this? X squared divided by x. X. It's two integrals. We have to realize that the properties, you can distribute an integral over addition and subtraction, not multiplication division. Whereas with exponents, you can't distribute an exponent over addition and subtraction, but you can over multiplication division. So distributive property works with certain combinations of operations. And we as math teachers need to be more particular about stressing those operations. I'll let you try that. I'm going to pause this and give you the handout for today. Because the problem with today's is going to be, okay, shh. Guys, we got to be quick. I want this done before we leave. This is just an area problem that's out of your book. I don't think it'll give anything to you this hard, because this is going to be on the non-graphing calculator part of the exam, unless they lied to us. But certainly we can do this one easily. Now, I know you guys like to solve for y, and I would normally solve for y, but in the interest of time today, all I need is how many points on the line to graph the line. Okay, you do recognize it's a line, right? Okay, so I added or 2. Why don't I try x equal to, what's the easiest x value I can put in? 0. Then what's y equal to? So I'm just going to cover up this. What's y equal to? Negative 16. Now, I can put y equal to an easy value. What's the easiest one there? 0. Yeah? Good luck. Good luck. You can try. Okay, what's x equal to if y is 0? 4. Okay, that's how I teach it in algebra. Just cover that up. This is called the intercept method of graphing. And so if they're nice numbers, I'll do that. I only have a slight problem here. Y equal to negative 16 is not on my graph. So, but I could solve for y a little bit. 4x minus y equals 16. What's y equal to? It's, careful, it's negative 4x. Or is that the other way? No, it's 4x. I taught myself to be careful. So it's what? 4x minus 16. So what's the slope? 4. So once I graph y is 0, x is 4, I can easily do this, go over 1, up 4. Let's see if I can do this. I'll have to fix it. There it is. Now, that's fine. I can put that in a calculator. Right now, you have to have y equals to do a calculator. That's the problem. So how are you going to do this one? First off, I can recognize that it kind of looks like this. If I switch x and y, so x squared minus 4y equals 4, I hope you can tell me what that graph would look like. I heard one answer.
Parabola.
It's a parabola. And so it would look like this, right? So if these are inverses, what would this one look like? A parabola, but it's what? Tilted, right? It's over on the side. Is that a function? No. Well, it is. We can solve for y so we can know what it looks like, or I can just plot some points. So if I take this one, let's keep it in red. If I keep this one and I let x equal 0, what's y equal to? 2 and, well, there's two answers, negative 2. If you solve for y, you are going to get a square root function, which is what this is. Yeah, that's the positive branch. That's the negative. I can let x be anything I want. So I've got 2 and negative 2. Is that correct? Okay, shh, you guys. It's a parabola on its side. How about if I let Adam, what if I let y equals 0? Then what's x equal to? X equals negative 1. And if you know what this thing, about what it looks like, I'm not making it accurate, by the way. If you put it on a graphing calculator, you'll see it. There it is. Now, you could solve this for y. Y squared equals 4x plus 4. And then what do you do? Because I want to make sure this is clear. Square root. And what is, can I square root each of those individually? I wish, but it would be wrong. Yeah, you can say of course not, but there'll be probably at least 10% that will do it. And what is the square root of y squared? I did not get that earlier today. But anyway. No, you can go to y equals plus or minus, but the problem is I'm not convinced that you understand that it really is this. I'm solving this. I'm looking to put this into here to make it true. The positive root works. That's the upper branch of my parabola. And I could also put in this. Remember, it's a square root function. It just takes this and reflects it over the axis. And those are basic graphing things that we should know, but I'm not convinced that we do. Okay. Guess what? We haven't done any calculus. We want to find this area. How are we going to slice this? Vertically or horizontally?
Horizontally.
Why? Well, I could still do it vertically. Here's the problem with slicing it vertically. Okay, guys? Miss a word, you miss a lot. This is the curve. Okay, guys? This is the curve minus the same curve. In other words, one's the positive square root, the one's the negative, which is not fun to deal with. Then over here, that would be the curve minus the line. Carolyn? That's the curve minus the line. I have to write two integrals. Do you guys want to write two integrals? I'd rather write one. So we can slice it the other way. Not necessarily just because of the way it's shaped, but you have to be careful with that. I have to actually draw the slices in. And each slice, each rectangle, there they are. How many rectangles am I going to put in here? Infinite. If I put in enough, these are really thick rectangles, you can see it's going to fill up that area, isn't it? Okay. Now, how do you find the area for one of those slices? Hey, Natalie, how do I find this area? It's not too hard to do. First off, what is this? Well, wait a minute. Let's find that. It's delta y. Does everybody see why it's delta y? If you were to extend it up, it hits the y-axis. That's a quick little trick. I don't like it. You see that that's the change in y. That's the base. And then you have to find out how long each one of these is. You want to call this one x2? That's fine. And so it's x2 minus x1. Notice I don't have the function involved yet. Or actually, not a function. I don't have the equations involved. Carolyn? So I want to find the total area, and I'm going to add it all up. It's x2 minus x1. And Mrs. Hersman suggested, and oh, it's not dx though, is it? It's dy. So these are always going to be opposite. Always. If you get x1, x2 minus x1, you make it dx, it's wrong. They're always going to be opposites. And so now this tells me I have to have my function in terms of, or my relation in terms of y. Okay? Here it is. So I need y's in there. But I liked what Mrs. Hersman did, is she went up here, and which one is the x2? The line or the curve? It's the line. Look at your picture. It's all geometry. So let's call this one x2, and then this will be x1. So what do you have to do with these two equations? You have to solve for x in terms of y, because you can only have y's in here. Well, I have to find where they intersect too. But so I have 4x2, and I like that little trick. Minus y is equal to what? 4? Was it? I just don't want to keep going back and forth, but I guess I have to because I don't want my sheets there. What was it? 16. Okay. So this is not a nice problem. 4x2 is equal to y plus 16. You guys are going to run out of time. Divide by what? 4. So x2 equals y over 4 plus 4. By the way, on the exam, if you write that here, you show your work, and you write this integral right there, you don't have to rewrite it with that ugly-looking equation in there. No problem. What's the other one? The other one was y squared minus 4x equals 4. See if I can remember that long enough. Y squared minus 4x equals 4. Solving for x, I get y squared minus 4 equals 4x. Did I do that too fast? Is that okay? Divide by 4. So, oh, that was x1. Sorry. So x1 equals y squared over 4. If you're talking, you can't be listening, Artavan. Forever. Okay. That's fine. As long as you clearly define what your equations are, you're fine. You do not have to put them back in the integral. Now for the next part, that's the tough part, we have to find where they intersect. And at least this is algebra. So I have this one, y squared minus 4 equals, no, not the original one. There's a trick to this. Minus 4x equals 4. And then I had the line, which was 4x minus y equals 16. Some of us, oops, that's minus y, equals 16. That is a nonlinear system. Okay, Carolyn, how do we solve nonlinear systems? You haven't had a lot of work with this. I could solve for x or y and substitute in the other one. I want to find the y's. So I'd probably Adam would solve for which one? X or y? I solve for x. I want all my y's, right? But it doesn't matter if I find x, then I can find the y. Okay, but you know what? Is anybody more clever than that? Does anybody see an easier way to do this? Cameron? Zach? Not doing substitution. Close. Not subtract. Just what? Add. Because what do you do when you add? You get y squared. That's what I loved about algebra. What's that give you? 0. They don't always work out nicely, but this one did. They will on the exam because they're not interested in the algebra. They're interested in, do you know the calculus and how to solve the problem. So the problem, don't make problems hard. When you do the problems and you practice and you make them hard, you're going to say, oh, I made that so hard. But the more you practice, the less you'll do that. Now, what I always see, and even as a grader I see this, okay, what is wrong with this? some of you like it, but what's wrong with it? It's wrong. Well, why can't I do that?
Y equals E.
This is not zero product property. This has to be zero. So, what do you do with any equation? To solve any equation, okay, Julian? Solve any equation, we set them equal to what? 0. So, if you can remember that, you can solve anything. Be it a calculated problem or a non-calculator, it's always 0. Can you factor that quickly because we're almost out of time? So the answers are 5 and -4. On the AP exam, that's good. At the University of Minnesota, that we don't have credit. You have to show all the steps, how you got from there to there. They're kind of old-fashioned. I don't see any problem with that. So what is that? Minus 5 to 4, was it? 5 to -4 to 5. So let me get my answer. Where was it? Ah. Now, this is a nasty one to integrate. Even putting on your calculator is not very fun. Okay? Oh, I didn't make the deadline. Uh-oh. Okay. It's time to go.
Hey, you're just